So I just wanted to go through all, examples of questions I had in the past done, you know, a full-on water treatment course, and some of the feedback I got was, I kind of want to see what's on the test. I've never taken the test before. I want to see examples of the questions, and I think this time around, I chose to just make a bunch of questions and go through them with you guys. With the answers, and you guys can, of course, all the PDFs were sent out, I believe, and you'll be able to keep all this stuff and be able to reference it and kind of brush up on a few things. And some of the question format is very similar to what you'll see on the state test. Now that it's being done on computer, I'm assuming that you'll be able to choose the A, B, C, D answer with the click of the mouse. So I'll just get right into it. Which of the following is removed at the raw water intake? So the raw water intake's the beginning of the treatment plant. Dissolved solids, obviously that's not going to be the answer because it's dissolved in the water. You can't remove that in intake. Turbidity is removed by filtration. Fish and debris, so that's an obvious answer right there. The raw water intake is to remove all of the large items, fish, debris. Some fish get through, but for the most part, that's what it's there to do. There's intake screens at the beginning of the plant to remove all the big stuff. So which of the following is removed at the raw water intake? And the answer is C, fish and debris. The raw water intake is designed to remove all the big stuff. Which of the following is more likely to be found in groundwater? Groundwater is water that percolates through soil. So the answer here is going to be B. Anything that goes through a lot of dirt is going to have a lot of minerals in it. So wells naturally have a lot of minerals which show up as hardness. What is most commonly used to control algae growth in reservoirs? A, ferric chloride. Ferric chloride is a coagulant, so that is not going to be growing in a reservoir. Trihalomethane is a carcinogen that is produced when chlorine interacts with organic matter in water, so it can't be that. C, sodium hypochlorite, that's a chemical used to disinfect. D is the answer. So all these answers are also at the end of this slideshow, so you guys don't got to worry about, writing this stuff down, because everyone should get a copy of this presentation as well so that you guys can reference it later. So the answer is D. D, copper sulfate is a chemical compound that is used to control algae growth in reservoirs. The best time to do this is at the beginning of the algae growth before it gets, too much to handle. So actually right now would be a good time to look into treating reservoirs with copper sulfate. What are common filtration rates of gravity filtration? So gravity filtration, this is the typical type of filter that you'll see at a water treatment plant. Usually has 12 inches of sand on the bottom, 24 inches or 24 to 48 inches of anthracite or granular activated carbon, GAC. And just from experience, C is going to be your answer, 2 to 10 gallons per minute per square foot. And that's typically what you see on a gravity filter. Leakage within a centrifugal pump is intended for what purpose? The leakage in centrifugal pump is to cool the moving parts in the pump, and it's used to lubricate. Relieving pressure, minimize vibration, prevent cavitation, those are not the answer. So as you can tell, kind of when you go through the test, you're going to see answers that you can kind of, through the process of elimination, get rid of some of these answers just because some of them are just way, are not going to be the answer. And you can kind of, as you go through the question. Another cool tip is like when you go through the exam, some questions will have an answer that will help you answer other questions. So that's another cool tip. Which of the following is the definition of a grab sample? A sample that is not adequate for making periodic measurement, it's not going to be that. A sample that is taken to represent the flow, a flow, that's not what a grab sample is. A composite sample, It's not a composite. So the answer is D, a single sample of water collected at a particular time and place, which represents the composition of the water only at that time and place. So a grab sample, when I'm asking an operator to do a grab sample of the chlorine residual as it leaves the clear well, I'm just grabbing a singular sample at that particular time. So the grab sample at 3 p.m. may be different than the grab sample at 4 p.m. Adding sodium hypochlorite to water will have the following effect. So sodium hypochlorite is bleach. Typically, we use a very strong concentration of it. Households going to be near 1%. We use about 12.5% concentration because we're dealing with a lot of water and we need a lot more bang for our buck. So when you add sodium hypochlorite to water, I think I heard the answer, which is good. So it's going to increase the pH. The pH of sodium hypochlorite is actually high on the pH scale. So when you add it to water, it's going to increase it. What is true about the total coliform rule? Specifies the log removal for bacteria and viruses, establishes an MCL based on the presence and absence of total coliforms or E. coli, does not require use of sampling plan, requires a sanitary survey for all systems. This is going to be B, establishes an MCL based on the presence and absence of total coliforms or E. coli. Total coliform rule is essentially the rule that requires 95% of all samples grabbed in the system be absent of, coliform E. coli. And that is to ensure that the water coming to the customers has adequately been disinfected and there is no introduction of any other contaminant to the water that would cause, gastrointestinal disease. So it's very important to conduct our TCR grabs in the system to ensure the water is continually disinfected for our customers and safe to drink. Which of the following will react with chlorine to form trihalomethanes? So this is going to be a repeated question. It's guaranteed it's going to be on your exam because of the effect of trihalomethanes have on people. It's a carcinogenic compound and it has been found to form cancer. So when you have naturally organic material in the water and you introduce it to chlorine, it will form high levels of trihalomethanes. An acronym for trihalomethanes is THMs. So that's something you'll see. What must be located near a hazardous chemical storage room? So the answer to this one is the safety data sheet, SDS, which is C. Safety data sheets are going to be found in any water treatment plant. They have a description of the chemical you're working with. It gives you explanation what the chemical is, what the hazards are of that chemical, what kind of personal protective equipment to wear, PPE. And it's a very important document that you can reference and get to know because you will be using very dangerous chemicals. You'll be taking chemical loads, deliveries, and all the pumps and the plumbing associated with that chemical leaks. So you will need to know what you're dealing with. What is the best way to monitor filter performance? So filter performance is it's the last stage in the water treatment process, right prior to disinfection. And one of the most important processes at the water treatment plant. And the answer is C, turbidity. We must ensure that our turbidity levels leaving the filters, individual filter effluent, turbidity, here at East Bay Mud, it has to be below 0.1 NTUs. NTUs is the unit of measurement. It stands for nephelometric turbidity units. And it's essentially the clarity of the water. The lower the turbidity, the less chlorine demand will be in that water, and the less chlorine you will need to use. The less chlorine you will need to use, the less THMs that may be formed. So it's very important for our treatment plants to reduce the turbidity as much as we can. And we do that through, the proper appliance of coagulants and properly operating sedimentation basin, and also a properly operating filter. What causes water to look cloudy? Dissolved solids, bicarbonates, hardness, suspended material. So it's D, it's suspended material. The thing, turbidity is caused by pretty much dirt in the water. So, and that's why we add the coagulants. So the coagulants adhere to the dirt. It combines, forms what we call flock, and in the sedimentation basin, through time and gravity, it sinks. And then the rest of the turbidity, which there are at that point very small amounts, will be taken out through filtration. Which sampling parameters must be taken in the field? The answer is A, pH and temperature. If the total coliform tests positive, then what must be done next? So test for pH, that's not going to be A. Test for fecal coliform, so the answer is B, test for fecal coliform. Anytime you have a coliform positive, a BACT positive, you're going to want to do a fecal coliform sample. And usually with the 24-hour col alert samples, you just put it under a fluorescent light and it'll fluoresce yellow if it's fecal coliform. And then from the visual, it'll be yellow after the prescribed incubation time. What is the definition of holding time for water samples? So the answer here is D, the length of time a water sample is retained between taking the sample and laboratory analysis. The reason why hold time is important is because certain samples can only be held for a certain amount of time before the result is invalidated. So it's very important for you as a water treatment operator to know the hold time of each of the samples that you are sending to a lab. Some of the hold times are 24 hours, some of the hold times can be 7 days, and some can be 30 days. Understanding those times helps in when you're shipping it, whether it's to an inside laboratory, in-house laboratory, or outside laboratory. From a bacteriological standpoint, what is important for a well? A, to protect it from contaminated runoff. B, use a thicker steel casing. C, drill shallow wells. D, keep water table high. So the answer is A. Contaminated runoff is very, that's what you want to protect a well from. Which is true about chlorine gas? Let's see. It is 4 times heavier than air. It is 2.5 times lighter than air. It is 2.5 times heavier than air. It is 4 times lighter than air. So the answer here is C. It is 2.5 times heavier than air. So chlorine does tend to sink. And that's, I don't know if anyone's a history buff, but in World War I, they used chlorine gas in the trench warfare for World War I because it would go to the lower areas of those trenches. Very deadly as a gas as well. Very dangerous substance. A lot of utilities do not use chlorine gas because of the danger and the regulatory requirements of keeping up with the system, making sure that it is safe to operate. If chlorine residual is not detected after 3 milligram per liter of dose is applied, then what might be occurring in the water? So A, too much chlorine has been added. B, sufficient chlorine dosage has been met. C, breakpoint chlorination has been surpassed. D, demand has not been met. So when in dealing with disinfection, everyone's got to understand the dosage is equal to the demand, the chlorine demand of the water plus your residual. So in this situation, if we fed 3 milligrams per liter of chlorine and we still do not have a residual, that means the demand has not been met. So the demand is greater than 3 milligrams per liter. For example, if we had water that had a demand of 4 milligrams per liter and you dose 5 milligrams per liter, the demand would be the 4 and then you would have a 1 milligram per liter residual at the end. Which of the following is an indicator organism for pathogens? The answer is C, coliform. So coliform bacteria is an indicator, and that's what we use in testing for pathogens in water treatment. What would happen if there is an increase in turbidity, organics, and manganese in the water? A decrease in chlorine demand, an increase in chlorine demand would be unaffected, increase in filter runtime. So the answer here is B, increase in chlorine demand. So anytime the first rainstorm of the year, and it's pretty much the toughest time in most surface water utilities in their treatment plants, especially if you're on a river. When you get that first rainstorm, all that runoff that goes into the rivers and streams carries a lot of turbidity. It's going to have a lot of organics, and all of which will increase the chlorine demand in the water. So when you do see that rainstorm, as a water treatment operator, you should increase your coagulant doses and increase your chlorine residual because you will see an increase in chlorine demand. Which of the following would increase alkalinity in water? Calcium carbonate, iron, manganese, or CO2? The answer is A, calcium carbonate. What is the definition of well drawdown? A, the distance to the nearest well. It's not going to be that. B, lowering of the water table due to drought. No. C, distance between static pumping and pumping water level. Ding, ding, ding. So what we're talking about a drawdown of a well. So when the pumping station is off, the water level will be at what we call static, meaning it should be static and equal with the pressure or the elevation of water around you. And when you start that pumping plant or well, you'll notice that the water level will drop, and that's what we call the drawdown. So it's the difference between the static level and now the new water level when the pump is pumping. What should be done with a water sample that cannot be analyzed in a timely manner? A, freeze it. B, refrigerate it. C, store at room temperature. D, add ammonia. The answer is B, refrigerate it. Almost all samples that we collect, we refrigerate them until they are collected, or when they are collected, they're put on ice so that it cools it, so that the lab can then put it in the refrigerator for analysis later. You can imagine these labs are collecting hundreds upon hundreds of samples, so they can't humanly measure each sample immediately when it's collected, so they're put in the fridge for storage until they can. Which of the following source waters would most likely contain cryptosporidium and giardia? A, an unconfined aquifer. B, groundwater. C, confined aquifer. Or D, a stream. So surface water is going to be the most likely to contain cryptosporidium and giardia. So it's D, stream. Anything underground actually is very protected, especially if it's a confined aquifer or groundwater. It's actually very, very clean and low in turbidity because the water percolates through the soil. The downfall of well water is very hard, so it'll really deposit all that the hardness into your pipes at home. What is the purpose of the chlorine residual? A, provides a safeguard to inactivate additional microorganisms encountered after treatment. B, chlorine used to oxidize iron and manganese. C, chlorine added prior to reaching breakpoint chlorination. Or D, chlorine added to oxidize nitrite. The answer is A. The purpose of a chlorine residual is to provide a safeguard to inactivate additional microorganisms encountered after treatment. There must be a continual chlorine residual after the water treatment plant and throughout the distribution system because it continues to safeguard that water against any type of microorganisms encountered. A lot of the tanks in our system, they have to be vented. They are open to the atmosphere. The vents do have screens, but those screens fail sometimes. And that's why we have an active chlorine residual that actively inactivates additional microorganisms encountered. This may be on the test, and this is in reference to disinfection, which is equivalent to 3 log removal. Anytime you see log removal, and whatever number it says, it could be 2 log removal, it could be 4 log removal. If it's 2 log removal, the answer would be B, 99%. And then if it's 3 log removal, it's 99.9%. So the answer to this question is C. Now, if it says 4 log removal, it's 99.99%. So you see the pattern there. You will be asked one of these questions on the exam. How is turbidity measured? Milligrams per liter? Nope. Parts per million? Nope. Percentage? Nope. Nephelometric. So nephelometric is the first letter in the acronym NTU, which we talked about earlier. Nephelometric turbidity units, and that's what we'll measure turbidity in. It's going to be NTU. Which chemical is used to dechlorinate water? Sodium hydroxide. Sodium hydroxide is caustic. Was there a question? Okay. Sodium thiosulfate is used to dechlorinate water. Sodium hypochlorite, that's a disinfectant. That's bleach. Sodium chloride is also another disinfectant. So sodium thiosulfite is used to dechlorinate water. What is the minimum chlorine residual required prior to introducing the effluent from a surface water treatment plant to the distribution? The minimum chlorine residual required prior to water entering the distribution system is A, 0.2 part per million. That is a very low chlorine residual, and is a chlorine residual that you probably don't want to put out. But depending on the system, actually, I can't even imagine a system wanting to do a 0.2, and that would be the very minimum. So the chlorine residual that we put out into the system right now, we use chloramines at East Bay Mine, so we measuring total chlorine. So we put out about 3.5 milligrams per liter. In free chlorinated systems, they put out much less. They'll put out about 1.5 parts per million because it's free chlorine. It's a lot stronger, and it's a lot more stable at the lower strength, or residual. What must you wear prior to being exposed to chlorine gas? Xenon protector, nanotech apparatus, SAS, or D, a self-contained breathing apparatus? The answer is D, SCBA.
So, SCBA.
Why isn't chlorine typically injected prior to filtration? To minimize capital costs of the plant, decreases oxidation, increases THMs, increases nitrification. The answer is C. Typically, you want to add your chlorine after filtration, because that's when your full removal of turbidity and any other constituents is done, and minimizes the chlorine demand. So if you add chlorine prior to, you will increase THM at the plant. Which of the following is a disinfection byproduct? So disinfection byproduct, also known as DBP, A, MTB, B, trichloroethylene, C, trihalomethane, D, tetrachloroethylene. So the answer is C, THMs, trihalomethane. Which of the following is not affected by chlorine dose? Hardness, iron, manganese, natural organic matters. So in this answer, it's going to be A, hardness. A, iron is actually affected by chlorine. Manganese is as well, and natural organic matters. That's a misspell right there too. So, how long should you run water before you take a grab sample? So this is in a grab sample that's collected out of a sample pump or a reservoir tap. And when you're grabbing this sample, especially if you hadn't ran it in a while, you should run it for 2 to 3 minutes in order to get a representative sample. So that's what you're always going to hear too. A representative sample. Is my sample representative of the water inside that reservoir, inside that pipe, or in that water treatment process? One of the best ways to make sure it is representative is to flush it 2 to 3 minutes. Which of the following is least likely to affect the effectiveness of chlorine? Sorry. So A, pH, B, temperature, C, turbidity. The answer is D, sodium. So this is least likely to affect the effectiveness of chlorine. So when you're looking at chlorine and in terms of disinfection, temperature is a huge factor. The higher the temperature, the hotter the water, the better, the more effective chlorine is at disinfecting. pH, when you're looking at pH, the lower the pH, the more effective chlorine is at disinfecting the water. Turbidity, lower turbidity. Sodium doesn't really affect it. When dealing with high pressure pipeline, which must you do? A, open and close valves quickly. That is not the answer. B, open valve quickly but close slowly. C, open and close valve slowly. Or D, open valve slowly but close quickly. Valves should never be operated quickly, especially if you're on a high pressure pipeline. There's something called water hammer, and it is a real thing. When you operate valves, please do your supervisor or manager a favor and open them and close them very slowly, especially if you've never operated them before. Which of the following water source is more likely to have iron and manganese? Lake, groundwater, river, or stream? The answer is A. Iron and manganese form when conditions in a lake or reservoir are such that the dissolved oxygen is very low. Fish live in these reservoirs and they breathe oxygen. And typically what happens over time is the lower levels of that reservoir, because it lacks, the wind up top, the wave action creates oxygenated water. And usually the top layers will have higher oxygen levels than the lower layers during when the reservoir is stratified, meaning it's got different temperatures in that reservoir from the sunlight. The lower levels will have low oxygen levels and will have iron and manganese because they precipitate out of the water when, they're in solution when there's no oxygen. What are colloidal particles? Very small particles that do not dissolve and remain dispersed in liquid for a long time due to their small size, electrical charge. That is the answer. So colloidal particles are very small and they're all kind of negatively charged. So they don't really settle. And that's important because that's why we add a coagulant to the water, so that we could put a different charge on them so that they can adhere to each other and form a large settleable flock. What is alkalinity? The capacity of water to neutralize base, pH of 5, the capacity of water to neutralize acid, or D, pH of 7. Alkalinity is C, the capacity of water to neutralize acid. So alkalinity is the buffering capacity of water. If I'm adding, going back to the previous question, the sodium hypochlorite, depending on the alkalinity of my water, if it's really low alkalinity, the ability for that water to change pH is very high because there's no buffering capacity. When there is a lot of alkalinity, the pH really doesn't change too much. It would take a lot of that sodium hypochlorite to change the pH of that water. So the alkalinity is the buffering capacity of the water to change pH. What does MCL stand for? The answer is D, maximum contaminant level. What typically occurs at the beginning of a breakpoint chlorination curve? So the breakpoint chlorination curve is the curve that describes, it's in relation to, you've got your chlorine dose. As your chlorine dose is, as you introduce water to, chlorine to water that doesn't have any chlorine in it first, the chlorine will destroy the reducing compounds and not form any residual. So the answer is D to this question. But as you keep on feeding chlorine, the residual will go up. And what's actually kind of interesting is it will reach a point where it will actually go down. And that's when it's forming a different type of chlorine compounds, the dyes and trichloramines. And then once you satisfy all the nitrogen in the water, you would have met the demand, and then you're going to start forming free and available chlorine residual. I didn't include a breakpoint curve on here because the state questions won't ask you that. But once you get to a utility, and especially if they chloraminate, you'll get to know that very well. What is the drawback of pre-chlorination? Formation of THMs. So again, you're going to hear a lot of THM questions. You're going to hear a lot of, what effects of chlorine and organic matter in the water. So you're going to get a lot of those questions in these exams. The answer is going to be A on this one, formation of THMs. Most utilities do pre-chlorinate, but the biggest part of the pre-chlorination question is how much of the chlorine are you added? A lot of utilities just add a small amount of chlorine at the pre-chlorine, chlorine at the beginning of the stage at the raw water to control algae growth and help out with the coagulation actually. As long as you don't add too much, you're not going to form too many THMs because you only really form THMs when there's the chlorine residual. The secondary MCL is set for what purpose? Health, bacteria and viruses, carcinogenics, aesthetic. The secondary MCL is aesthetic. The answer is D. What is used to lower pH in water? CO2, calcium carbonate, sodium hypochlorite, ammonia. And the answer is A, CO2. Every fast food restaurant has a CO2 system and actually lowers all the pH. It's pretty common. It's essentially a lot of utilities too add CO2 systems to lower the pH. The only thing about CO2 that is that it is a weak acid. Carbonic acid is what it will form. And some utilities that have higher alkalinity water, and remember when I was talking about alkalinity, it's the buffering capacity of water. They'll have an acid system, an actual acid system there. So CO2 would be very expensive to operate if your water had high alkalinity. Why is trihalomethanes considered to be harmful? So the answer is D. It is a carcinogen. Which of the following describes turbidity? The answer is D. Cloudiness of haziness of a fluid caused by suspended solids. What is typically the cause of taste and odor problems in raw surface water? D, algae growth. That's going to be the root of all, typically all the taste and odor problems. Tastes like dirt, tastes like, it's going to be algae. What are the 4 zones of a clarifier? The answer is D. I'm kind of going through these last ones quickly because I do have some math questions at the end I wanted to go through. What might occur after a filter has been backwashed? So the first thing that we do after a filter is backwashed is we put the filter, if we're going to bring it in service, we're going to put it in filter to waste. So what we'll see when you do that is the turbidity on C will momentarily increase in the filter. Well, hopefully on this one, it's going to be your filter to waste. So the water won't be going to the effluent. And that's why we do that. What is 4-log removal? I shouldn't have to say the answer to this because we kind of talked about it, but it's A, 99.99%. So again, 2-log removal is 99, 3-log removal is 99.9, 4-log removal is 99.99. What is considered to be a base? So the answer is D, in the pH range of 8 to 14. What organism is capable of causing disease? A pathogen. What is an example of combined chlorine? So in this example, it should be D, monochloramine. Okay, so here's a few math problems I wanted to go through with everyone. I know we don't have much time, but so this question asks you to convert 5 cubic feet per second to MGD. So I kind of copy and pasted from the book, and how the math would look like when you're converting to 5 cubic feet. Let's see here, 5 cubic feet per second to MGD. So the relationship here is the 7.48 cubic feet equals 1 gallon. So, and then you'll see that in this example, 7.48 gallons per cubic foot. Excuse me. So you got your 5 cubic feet, and you're doing your time conversion up top. So that's feet per second, 60 seconds in a minute, 60 minutes in an hour, 24 hours in a day. So you got 432,000 cubic feet per day. And now you're converting the 432,000 cubic feet per day to gallons by using the conversion of 7.48 gallons per cubic foot. And then you're going to get 3.2 million gallons per day. So these are slides that you'll be able to keep in reference and study for the exam, and hopefully it helps you out. How long will it take for water to pass through a rectangular basin at a flow rate of 1.3 mgd? If the basin is 80 feet long, 40 feet wide, and 10 feet deep. This is a detention time question. And these rectangular basins are what we call sedimentation basins. So detention time equals volume over flow rate. And first thing, we've got our volume 80 by 40 by 10, and that's going to give us 32,000 cubic feet. We know the conversion of cubic feet to gallons, so you multiply that by 7.48, you're going to get about 240,000 gallons there. And then you're dividing that into 1.3 mgd. So then we'll do the calculation below. The conversion here, since it's in 239,000 gallons, you're going to convert it to 1 million gallons a day by putting 1 mgd over 1 million gallons per day. And then you get 0.18 days. And they wanted to answer in hours. So there we see you multiplied 0.18 times 24. And then you get the 4.4 hours, which is D. A tank with a diameter of 60 feet and a height of 20 feet is located 40 feet above the pipeline. What must the pressure be in the pipeline to completely fill this tank? Assume that pipe friction head loss are negligible. So this is a thing that the state test does as well. They give you extra information. When you're doing a pressure question, the diameter is negligible. You don't even need to know that. You just need to know vertical distance. So this is actually a very simple question. And they always try to do this. They give you extra info when you don't need it. So just remember, when you're doing pressure, all you're thinking about is the vertical distance. So in this example, you have a 20-foot height of the tank, and then you have 40 feet, and it's 40 feet above a pipeline. 20 plus 40 is 60 feet of head. That's what we'll refer that to. And then the conversion there is 0.433 PSI per foot, which is 26 pounds per square inch. An 18-inch diameter pipe that is 1 mile long is filled with water at a rate of 500 GPM. How long will it take to fill this pipe? So 0.785 is a standard number, and then you're going to use that times the diameter squared. Here they put 18 over 12 because they want you to get to feet. Then there's 12 inches in a foot. So the math there will equal out to 9,326 cubic feet over 500 gallons per minute. And then you'll further convert that. You'll use your conversion of 7.48 gallons to cubic feet. And then you divide that into the 500 GPM, and then you're going to get about 140 minutes. And then the last step is to convert to hours. And there, we all know that there's 60 minutes in 1 hour. So 2.3 hours. The answer is B. If a tank with a diameter of 40 feet and a height of 20 is full at 8 a.m., is draining at a rate of 200 gallons per minute, then what is the water level in the tank at 4 p.m.? So this is a typical distribution question. So calculate how many hours of flow. 8 hours of flow from 8 a.m. to 4 p.m. You can use military time, 1600, and then maybe you'll get the math a little bit easier. 16 minus the 8 is 8 hours of flow. Then you get the volume of the tank. Again, we use our standard 0.785 times diameter squared times the height to get the volume of that tank. So the full volume is about 25,000 cubic feet. And then again, you're gonna get to know 7.48 gallons per cubic foot very well, because you're gonna get the gallons now. So 25,120 cubic feet times 7.48 gallons. because that's equal to 1 cubic foot, and you get 187,897 gallons of water. So now you want to see the amount of water leaving, right? So you got 200 gallons of water leaving a minute, and then you're going to convert that to how much will leave in 8 hours, because we're doing 8 hours of time, times the 60 times the 8. And then you're going to get, okay, in this 8 hours, we've got 96,000 gallons of water leaving. And then now you just plug in what's remaining. And it's the simple math, the 187,897.6 gallons minus the 96,000. And then you'll get the answer of 91,897 gallons. And then you'll then you'll do the backwards, where you're going to convert it to cubic feet. And then you could plug in your same diameter to get the height. See how that works there? So in this example, it's 9.8 feet. Let's see. If the water meter reads 2,000 at 10 a.m. and 3,000 24 hours later, what is the water usage, assuming each unit equals 1,000 gallons? So 3,000 minus the 2,000, that's the 24-hour usage, 1,000 units. 1,000 units times 1,000 gallons, because 1 unit is 1,000. And then you get 1 million gallons. So the answer was D. If 35 pounds of 65% calcium hypochlorite tablet is placed inside a tank, then what is the concentration of the water if there is 1,400,000 gallons in the tank? So on this example, you're going to take the 35 pounds times it by the concentration, 22.75 pounds. You're going to use your pounds formula. Pounds equals the dose times your mg times the weight of water, 8.34 pounds per gallon. And then you just plug in the numbers. 22.75 pounds equals X is the variable, that's your dose. We don't know that yet. So you're going to take the 1.4 times 8.34, and then that'll give you, and then, yeah, do the math there and solve for X, and you'll get 1.9 milligrams per liter. So these are the answers for all the slides. It's it may come to you as a page number, but hopefully you'll be able to go through this and be very helpful to you guys.